Right, we're looking at differentiation here, and it says the curve C has that equation. Find the turning points and the nature of those turning points. Now, the turning points are where the gradient equals 0, and the nature of those turning points are whether they're a maximum or minimum. Remember, a maximum is going to look something like that, and a minimum is going to look something like that. Okay, so first things first, I don't want that in brackets. I'm going to multiply all that out, so a stage at a time. Okay, remember I like working in stages. So we're going to get minus 8x plus 16, right, and that multiplies out to make x cubed minus 9x squared, right, and I am actually missing out one stage here purely because I'm going to run out of room if I'm not careful. But if you want to add another step in there, that's absolutely fine, but I've simplified everything. I'm now going to differentiate that. So I'm going to find dy dx, and when I differentiate x cubed I get 3x squared, differentiate minus 9x squared I get minus 18x, differentiate plus 24x I get plus 24, right, and differentiate minus 16, nothing occurs. Now, as I said, to find where, and I'll do this bit in red, where there's turning points, the gradient equals 0. So I'm going to be asked to basically solve this equation. Right, now you may well have noticed that all of those coefficients, okay, they all divide by 3, so I can divide everything by 3 and it makes it a lot nicer for me. Okay, plus 8, and that's going to factorise nicely, so I'm going to get x minus 4 and x minus 2. Okay, now when I get x minus 4 and x minus 2, that gives me my x coordinates of 4 and 2, and I can put them back into my original equation by doing, where are we there? By putting those x values back up into there. Okay, and when I do that I get 4 and 0. Okay, so they're the coordinates of the turning points. So it's, sorry, what am I doing? Sorry, I do apologise, I've done it the wrong way round. There we go. So it should be 0, sorry, and 4. Okay, so there you go. The points where there's the gradient 0 is 4, 0 and 2, 4. Now I need to determine whether those points are maximum or minimums, whether they're sort of a hump or a trough, as it were. So in order to do that, the best way to do that is to differentiate again. So I'm going to find d2y dx squared, sometimes called f double dashed, right? Because we're using dy dx, I'm going to use d2y dx squared, and 3x squared differentiates to 6x, and minus 18x differentiates to minus 18, plus 24 disappears, as it were. Okay, now then, when x is what have we got, 4, right, 6 times 4 is 24, minus 18, d2y dx squared, and that's is greater than 0, so that means that is a minimum. Okay, so remember, when d2y dx squared is greater than 0 at that x point, then you get a minimum, and therefore you can probably guess, but you never know, when x equals to d2y dx squared is less than 0, so therefore you've got a maximum. Alright, now that would be, what, a 4-mark, 5-mark question probably, that's maybe even more. But they would be expecting to see all of those steps, okay, and so therefore what you could add, I'll just get me a purple pen back out, so you could add, 4, 0 minimum and 2, 4 maximum. Alright, but as long as you show all the workings, you're pretty much done there.